standard deviation of a numerical data set is a measure of how much a typical value in the data set differs from the mean. The symbol sigma represents a standard deviation. It is where the sigma and is given by the equation sigma equals x1, which will be your first x value, minus x bar. X bar is the mean or the average, and then squaring that value after subtracting. And then we'll add to that x2, which is the second x value or second value given, subtracting again x bar, which is the mean or the average, squaring, and then adding to that the third x value, and again subtracting the mean and squaring, so on and so forth until you get to xn, which is the last x value, minus x bar or the average, and squaring those values. After subtracting all of the x's off the average and squaring each of those individually and adding or the summation, we'll divide by n, which is the number or amount of numbers that you have, and then finally taking the square root of the radical of that value will give us sigma or the standard deviation. N again is the number of values of the data set. The deviation of a data value x is a difference of the data value and the mean of the data set, shown by x minus x bar. X is the given value minus x bar, which is the mean or the average. Steps are laid out below. First, find the mean or the average, then subtract each deviation from the data value. We'll square each deviation. Find the mean, which means you'll add up all those values and then divide by how many numbers there are of the squared deviation. This is called the variance. And then the last part, take the square root of the variance, and that will give you sigma, which is the standard deviation. And again, standard deviation is the measure of how much a typical value of a data set differs from the mean. Title of the next section is variance and standard deviation. If you recall from the equation, the variance will be the first value, and after we take the square root, we'll be given the standard deviation, which again is the measure of how much a typical value is set apart from the mean. First data set is a list of numbers. There's a single 4, followed by 5 5s, followed by 4 6s, followed by 4 7s, and then a single 8 and a single 9. Using the previous equation, we can find the variance and then find the standard deviation of this data set, which will tell us how far apart the data is spread from the mean. If you recall from the equation, we need to find a few numbers. The first number that we need is x bar. X bar again is the mean or the average. To find the mean or the average, you first add up all your numbers given in your data set. 4 plus 5 5s plus 4 6s plus 4 7s plus 8 and plus 9. Taking the sum of all the data, that adds up to 98. To find the average of the data set, we can divide by the amount of numbers. Counting the numbers up, there are 16 numbers altogether, so we will divide by 16. 98 divided by 16 would be 6.125. If we want to round this decimal, we can take a single decimal number, so the average or mean is about 6.1, or x bar of the data set is about 6.1. The next part to the equation is x1 minus x bar, or all the x's subtracted from x bar. Taking our first value 4 and subtracting 6.1, that would give us a negative 2.1. If you recall from the formula, that value is then squared. Following with the next number 5, subtracting 6.1. 5 minus 6.1 would be negative 1.1, and again that value would be squared. We could repeat this for each of the 5 values. Since all 5s are the same, we can multiply this value by 5, and that would be the same as squaring this number 5 times and then adding it. Our next number in the sequence is 6. 6 minus the average or the mean would be negative 0.1, and that value again is squared. And again, we have 4 6's, so instead of solving the question 4 times, we can multiply this value by 4 for our variance and standard deviation. The next value is 7. 7 minus 6.1 will give us a positive value of 0.9. And again, we will square that value. The last two numbers are 8, subtracting off 6.1, and 9, subtracting off 6.1. 8 minus 6.1 would be 1.9 squared. And the last value, 9 minus 6.1, would be 2.9 squared. Continuing to solve this equation, negative 2.1 squared will give us the value of 4.4. Negative 1.1 squared will give us the value of 1.2. And again, we'll multiply this by 5 to represent the 5 5s that were given above. Negative 0.1 squared would be 0.01. And again, we'll multiply by 4 to represent the 4 6's that were given above. 0.9 squared would be 0.81. And 1.9 squared would be 3.6. And last number, 2.9 squared, would be 8.4. 1.2 times 5 would be 6. And 0.01 times 4 would be 0.04. If we bring down our other values, we have 4.4 plus 6 plus 0.04 plus 0.81 plus 3.6 plus 8.4. Adding these values together will give us a total or sum of 25.68. And again, this number represents the numerator in the equation, where we subtracted all of the x's or data points from x bar, squared each value, and added them all together. The equation given before is a fraction. The denominator, you are dividing by n. N is the number of original numbers, which is also the number we divided by for our x bar or mean. So to find our first answer for the variance, variance would be the difference of all the x and x bars squared. After summing those divided by 16, that would give us a value of 1.605. And this number would be the variance for the data set given. The second part of the equation, or final part, is the sigma or standard deviation. By taking the square root of the variance, or the square root of 1.605, that value would be 1.26, and 1.26 again would be sigma, or also known as the standard deviation. The standard deviation, again, of a numerical data set is a measure of how much a typical value in a data set differs from the mean. The larger this value, the more data is spread out. The smaller this value, the closer the data is together.